This is Don Högberg. So I'm the contact person for the subject area human in the VF-KDO profile. And what Aitor, who is a PhD student at University of Skövde, will soon show is a demonstrator or part of a demonstrator, I would like to say, of a software platform that he develops in his PhD that enables the concurrent optimization of both ergonomics and productivity at the same time. I mean, today it's normally done by different people at different occasions in the development process. But this solution that Aitor develops called EPP enables a joint tool where ergonomics and production engineer can work together. And again, it's done together with Scania. So I hand over to you, Aitor. Ready?
Okay. So, hello everyone. As Dan said, my name is Aitor and I do my PhD in optimization of ergonomics. For that, we use digital human modeling tools, and in this case, I'm using IPS IMMA. So IPS is a simulation tool that we can use for simulation of robots and at the same time, simulation of humans. So in this case, what we are trying to represent is the model of the Scania Smart Factory. So in this Smart Factory, what we do is to simulate the production of a pedal car. So this is typically used in Scania in order to test new functionalities, new technologies related to Industry 4.0, and at the same time train the workers before they enter the lines in order to understand the assembling processes of Scania. So in this case, I'm representing the first workstation, and in the first workstation, we have a person trying to assemble the front frame of the pedal car. So when we make a simulation in this software, what we obtain is the sequence of a human performing the action. So this is a very initial model of this. But then this IPS IMMA tool, we develop it in collaboration with FCC, Chalmers in Gothenburg. So we also developed an additional tool here in Skövde, which is called Ergonomics in Production Platform. And this tool is developed entirely in our department and mostly in my PhD. So in this tool, what we can do is to export all this ergonomic information and try to analyze it. So when we import all the information from the software, we are able to analyze the humans involved in these operations and then try to see the ergonomic evaluations of these sequences. So as you can see, here in the right, we are evaluating it with REBA, which is Rapid Entire Body Assessment. So in this case, we are trying to see how is the ergonomics evaluation for this kind of operation. But once we have analyzed the actual situation, what we want to do is to improve it. So in order to improve it, what we do is use the optimization module. So in this case, I have a preload optimization, which is trying to optimize the height of the pedal car by checking on the ergonomics of the worker. So what we do is we can access all the solids in the entire scene, and then we can try to rerun the simulation with different parameters or different locations of these objects and check on the ergonomics in each of the iterations. So in this case, for example, we can define different positioning for the pedal car, and we can define different heights for this one. And then we can create different variables for these solids. So in this case, as you can see, I can define a variable and then I can go to the next step, which is the optimization objectives. So typically the optimization objectives are based on productivity, such as throughput and work in progress. But in this case, the new stuff that this platform is bringing is that you can also select the ergonomics of the workers. So if we select workers, we can try to optimize to reduce different factors of the workers. So if we want to focus in the lower back of the workers and try to improve that, we can just check on that. or we can use ergonomic evaluation methods like the one that I said before. And then we can select to improve the ergonomics of this for the most extreme postures or for the postures that are more repeated during the day. So in this case, we will be reducing the musculoskeletal disorders these workers can have in the line. So in this case, we can select the maximum values or the average values. So in this case, I have performed the optimization by using average values. Then we can define different constraints in the workstation, and we can define more outputs that we want to observe. Then we can build some relations between the solids where we can say that if this solid moves, this one should follow it or should have an offset to this one. And finally, we can define the optimization algorithm. In this case, everything that is set up in here will be also sent to OPT. So the OPT will use this information to use different algorithms in order to perform the optimization. We can also define how many simulation frames per second we want to use. So in this case, I'm using 5 frames per second. The higher is the frequency of the simulation, the more accurate the results will be, but it will take more time to perform the simulations. Once we have defined all the optimization process, now we can go to the results that I have preloaded. In this case, we can try to look at the different results and load different iterations of different evaluations of this optimization into the scene. But for that, we can take a look at the experiment browser, to the OPT browser. So then we can check on the different ergonomics of the mannequins, and we can try to optimize the pedal car for them. So in this case, we have one mannequin, and if we want to reduce the risk of this mannequin having some musculoskeletal disorders, then we can just lower the filter, and then we can see the best solutions for this mannequin, which will be at this height of the pedal car. However, most of the times, we are not having a single worker all the time in the same workstation. So it's also necessary to consider diversity. And if the case is that we cannot adjust the height of a workstation for every worker when they change the turn, then we need to adjust the height for all the workers at the same time. So in this case, instead of having just one mannequin or one worker in the workstation, we can check what it will happen if we will have several workers in that workstation. So we can see that each worker behaves a little bit differently depending on the anthropometrics they have. So in this case, we try to represent different heights and also reachabilities of the workers to see how the extreme cases could behave. So we optimize for just one type of worker in this case, and this could bring us some issues when we consider diversity. So if we add more workers to this solution, what we can see is that we were optimizing for a single worker, and then we were obtaining quite bad results for the rest. So one of the main ideas of this is that we should not try to make it the best for the standard worker, but we should try to represent the entire diversity that we have at the factories and then try to optimize for all of them at the same time. So we can see that in this case, if we go a little bit back on this filter, we can find more solutions. And these solutions, even if they are a little bit worse for the first worker that we were analyzing, they are much better for the rest of the workers. So in this case, we are going to try to see how these results are. We look at the iteration number of these evaluations that we have just made, and then we can load them into the scene. So in this case, the iteration number 95 was the best solution for all of them. So then we load the iteration, and you can see that the scene is changing and all the simulation is being rerun. So once the simulation has finished running, we are supposed to have the optimal result for the simulation. So now you can see that the workers are having a different height. And now is supposed to be a good ergonomic situation for all the workers at the same time. So this is a very first initial use case where we are trying to work with just a single variable, but we wanted to add these ergonomic factors into the optimizations. And at the same time, we also wanted to add several mannequins. This means that we wanted to represent some diversity. So in our future studies, what we plan to do is to include more variables, to use different ergonomic evaluation methods, and try to identify the most critical cases that we can have for the ergonomic risk of the workers in factories. And then try to optimize for both the ergonomics of those workers, but at the same time the productivity of the workers. So then we can try to shorten the cycle time of the workstations at the same time that we are improving the work quality for those workers.